Okay, so we're going to be solving equations where if you look at your equal sign, you have variables on both sides. So to solve these equations, we're going to go ahead and collect the variables on one side of the equal sign and then work to get that variable by itself. Now, some of you prefer where you've got the x on the left-hand side, and if you want to do that, that's perfectly fine. But when I look at this sample that I have right now, if this is my equal sign, I really want to get the x's to one side. So I'm going to go ahead and work by getting rid of this first. Okay, and I'm still going to keep that 2 with that x, so I'm not separating it right now. I'm thinking of what is the opposite of a minus 2x. Well, that would be plus 2x. Okay, and the only time you do this is when you have the x's on both sides of the equal sign. So over here, I'm going to say plus 2x. Okay, that canceled that out here. So over here, I have 15, that's not crossed out, my equal sign, and then negative 7 plus 2. These are different symbols, find the difference, which is 5. The larger number was 7, it had a negative, so it's negative 5x. Okay. Now, I do want to point out to you that you would get the same thing if you went through and shifted everything to the left-hand side. So right now, this is what we just found out by working and moving the x that was with the constant or the plain number. We had 15 equals negative 5x. So just to prove to you that it doesn't matter which x you choose to move. Sometimes there's a smarter move that's less moves than another. Had I chosen to maybe move so that my x's were on the left side of the equal sign, I could do that. Okay, right now this one right here is negative 7x. Well, the opposite of negative 7 would be plus 7x. Okay, that cancels out. So here's my x's, so plus 7x. I'm doing like terms, right? So now I have a 15. Negative 2 plus 7 gives me positive 5. X equals, there's nothing here. Okay, so the problem with doing it that way, where I ended up moving the x's so that they were on the left, because that's where I prefer them, is then I have nothing that's left on the right-hand side of the equal sign. So that means I'm going to have to do another step to work to get so that there is something over there. So I'm going to move this constant right here, the 15, and I'm going to shift it to the other side. But I still, because I'm only moving that one part, I have to do the opposite to shift it to the opposite side. So right now this is positive 15. I would do minus 15. Minus 15. Okay, so you may now be looking at this compared to this. And some of you might say, but Mrs. Swanson, and one of them you have a positive 15, and the other one you have a negative 15. So you must have done something wrong. Remember, we're still working to get x by itself. So if I chose to work the first method, well, how would I get rid of this negative 5 away from the x? Right now it's multiplying, I would divide by negative 5. Divide by negative 5. So 15 divided by 5 is 3. There's one negative, so it's a negative 3 is what x equals. So let's check and see what we would get here. On this side over here, I have a positive 5 that I'm going to move away from the x. So divide by positive 5. Divide by positive 5. Take note, we still did the 15 divided by 5 and got 3. There's still one negative. It's still negative 3. So we got the same answer either way. This format that I did, because I didn't choose to get the x's by themselves in the first step, I had to do one additional step, okay? But if you prefer to have the x's on the left-hand side of the equal sign, then you may have to do that extra step. Okay, and this is always confusing because you're so used to getting rid of that non-letter first. So this is just, you have to train your brain to look at these problems a little bit differently. Okay, so here I have a negative 3x. Here's my equal sign. I always do this because I know that I want to get all of my x's to one side of that line. Okay, and then I want the non-x's on the other side. So let's get rid of this 2x, right? Because here x is already by itself, but let's move this 2x. Okay, right now it's a positive 2x. The opposite would be negative 2x, so minus 2x. Negative 2x though, Mrs. Swanson. Well, negative 2 and minus 2, same thing. Whatever I did to one side, I have to do to the other. Okay, so now, like terms, same symbol, find the sum. And if you're not good with these and you're practicing them, do it in your head, then check it on a calculator. Okay, because that's one spot where it's really easy to make mistakes. So same symbol, find the sum, which is 5. Apply the same symbol, negative, put my x, equals 19. Now realize that sometimes, you guys, you are going to get numbers where we have decimal answers. Okay, if you're ever questioning, like I know here, lots of times you guys are used to just getting those nice perfect whole numbers. I must have done it wrong. If you're ever questioning it, ask. I'll go through and check your work and make sure you did everything right, because sometimes you are going to get decimal or fraction numbers. So now when I go through, I want to get this -5 away from the x. Right now it's multiplying. We're going to divide by, take the negative with it because you want just x by itself. Divide by -5. Okay, so now if you go through and you divide that out, I can tell you right now it's going to be a negative answer because we only have one negative sign between these two. So I know it's negative. Now, if you're not comfortable dividing that out longhand, I'm not checking your division. You can use your calculator, 19 divided by 5. And if you know that rule of, hey, there's only one negative, then you don't have to figure out how to use that negative symbol. So you should have gotten -3.8. Okay, if I ever want to check myself, I can do that. And I know there's not too many of you that prefer to do that. But if I want to check it, I'm going to rewrite this. So I have -3 times -3.8 is what I just got for x equals 2 times -3.8. And then plus 19. So now I could use my calculator to go through and check it. And this is just my arrow. I looked at that at first and thought it was a number. Okay, so now if I do 3 times -3.8, those are two negatives. When I multiply and divide, I get to count negatives. So I know it's going to be a positive. So 3 times 3.8 gives me 11.4. Now, when I go to do this side over here, and I work that out, I should end up with 11.4. So I'm going to do the 2 times 3.8, and it's 7.6, but really that's a -7.6. Okay, so now you either have to understand how to use your calculator and do that negative sign, or you can think in terms of this is addition, so different symbols find the difference, which is what I'm comfortable with, and then apply the larger sign. So I know it's going to be a positive answer over here because 19 was larger. So I'm just going to take 19, find the difference, minus 7.6. And when I do that, it should give me 11.4, and it did. So that's how you can check yourself. I know it's a lot of steps. Lots of times I will just check with maybe a partner to see if I got the same answer. Okay, remember, if you didn't work together and you both get the same answer, most likely you're both correct. Not 100% of the time, but most of the time you are, okay? So you don't have to go through all of those steps of checking it, but if you're by yourself at home and you want to do a quick check because there I got, what was it, 3.8 or whatever it was, and sometimes you just really question yourself, is that right? You can always check by substituting in. Okay, so let's try one more. Okay, so looking at this, here's my equal sign, right? So we want to get the y's on one side and the constants, or in other words, the non-y's on the other side. And it doesn't matter which side you choose to move. Some of you, as you start working with these, will say, I always want to move the y's so that they are positive. Okay, but that is totally up to you. If you always want your y's on the left-hand side, and you're comfortable with working with negatives, then it doesn't really matter. Okay, so I'm going to go ahead and work. I'm just going to work because I like to see the y's on the left side. So this right now is positive 4.5y, so opposite is negative. And we're taking the y with it right now because we're shifting to get the y's to one side. So that's why the y goes with it. So minus 4.5. Okay. So when I go through and I put these together, 2.5 minus 4.5, those are different symbols, find the difference. So the difference between those is 2. The larger number was negative, so I get -2y. Now, if you need to use a calculator, use it. You punch it in exactly as you see it. 2.5 minus 4.5, it's still going to give you -2. So now I have plus 6 equals, and then I still have this -1. Okay, so now I'm going to go through and get my constants or my just numbers. So right now I'm at plus 6, it's minus 6 is the opposite. Minus 6. So -2y equals -1 minus 6 gives me -7. Okay, and once again, here I'm looking at it and I myself, same thing, I myself am second guessing myself because I'm going to get a decimal. So don't think that you're the only one that ever second guesses yourself. Sometimes when I work through these, I say, oh, I was hoping to get a nice perfect whole number. I must be wrong. Okay, be confident in yourself, work your way through it, check with a partner, or substitute in. So now when I go through to do this, let's say now I'm gonna get that negative two away from y. So divide by two, negative two. So now 7 divided by 2 is 3.5. Both of them were negative, so two negatives make a positive sign. So y equals 3.5. If you want to